In this video, we're going to take a look at bonding, and specifically, we're going to take a look at the kind of bonds that form in a compound called an ionic compound. So let's start by defining what an ionic compound is. An ionic compound is a compound that's formed between a metal ion and a non-metal ion. And we have some terminology here. So for a metal ion, when it becomes an ion, it's going to lose electrons, and we call that a cation. So something like sodium or Na+, the sodium ion, would be a cation. A nonmetal ion will gain electrons, and so it is called an anion. And something like the chloride ion is an anion. And they will gain or lose electrons until they have a full valence shell. That's really the goal in bonding, is to have full valence shells. The electrons are transferred from the metal to the nonmetal. And then when the ions are formed, they attract one another in order to form what we call an ionic bond. So an ionic bond is not actually two things physically bonded together, but instead it's the attraction between two or more ions. Now, in terms of their properties, ionic compounds have some pretty interesting physical properties. For example, in the solid state, when we have solid ionic compounds, they form crystals that have this alternating arrangement of positively charged and negatively charged ions. So taking a look at our picture here, you can see chloride ions and sodium ions, and they're alternating back and forth in this really, really regular kind of structure. In terms of some physical properties, they're hard, they're brittle, they have very, very high melting points. So let's take a closer look at ionic bonding then, because it really kind of involves three key steps. The first step is losing of valence electrons by the metal. And so that's shown in our picture over here in step 1, where we have a sodium atom, and it's going to lose its one valence electron to become an ion. And in step 2 then, the nonmetal is going to gain those valence electrons. And so if we take a look at the chlorine atom, it needs one valence electron in order to have a full valence shell. And so the electron goes from the sodium, the metal, to the chlorine, the nonmetal. And then finally, once we've created the ions here, we have that attraction between the positive and negatively charged ions, and that creates our ionic bond. So you can see from this picture, we have full valence shell for sodium, we have a full valence shell for chlorine. They are charged positively and negatively. They're not physically bonded together though, but they are attracted to each other. Okay, so knowing that, let's take another look at one more example, because it's not always just one electron that gets transferred from the metal to the nonmetal. Sometimes it's more, depending on how many valence electrons we have. Now, if we take a look at calcium, calcium has 20 electrons total. And if we were to do the Bohr-Rutherford diagram, it'd have 2 in the first shell, have 8 in the next, it'd have 8 in the next. So that's 18, and then it'd have 2 in its final shell. Now, to make this diagram just a little bit easier to see, I'm just going to draw the 2 valence electrons, because those are the ones that matter in bonding. So calcium has 2, and then fluorine, if we take a look at fluorine, it has 9 electrons. So it would have 2 electrons in its first shell and 7 in its second shell. Again, I want to make this easier to see, so I'm just going to draw in the valence electrons around this fluorine here, like so. Okay, so because chlorine has 2 valence electrons, in order to have a full valence shell, it wants to lose 2 electrons. Okay, each fluorine will want to gain 1 electron. All right, so how does this work? Well, calcium can give up 1 electron to the fluorine. Okay, and that gets rid of 1 of the electrons from calcium, giving fluorine a full valence shell, but then we still have 1 more electron from the calcium that we need to give up in order for this to work. So what actually happens here is that it's going to give it up to another fluorine atom. And we kind of continue in this manner until all of the valence shells are satisfied for each of the metal and the nonmetal. Okay, so that second electron can go to the fluorine, and now calcium would have a full valence shell, and both fluorine atoms would also have a full valence shell. And this, we'll see, is where we get formulas from, because formulas are essentially telling us how many calcium and how many fluorine, or how many of the metal and how many of the nonmetal are going to combine together to form an ionic compound. For every 1 calcium, we need 2 fluorines, and that's where our formulas come from. That's it then for this video. Let's move on to our next task.